Hi, and welcome all to BootCamp, IO BootCamp. Today we'll be talking about optimizing your web performance for success. My co-presenters are Andrew Oates and Shawn Ligocki. I'm Richard Rabbat, and we will be taking turns. But first, agenda. I will be motivating why one needs to pay attention to speed, motivating it obviously by revenue. Everybody's very interested in making money on the web. Then Andrew will be talking about a new API that we're releasing today, which is the PageSpeed Online API. He will have a really cool demo about it. And finally, Shawn will be presenting Mod PageSpeed, which is an Apache module that allows you to speed up your web pages automatically. So performance equals revenue. Let's look a little bit about what's been happening with web pages over the past few months. This is data from HTTP archive. I picked the data about images as well as JavaScript transfer size. And from November of last year through March of this year, images on web pages have gone bigger. There's more images, and they are getting bigger. These are for the about 10,000 top web pages on the web, Alexa about 10,000. If you look at the JavaScript, it's also slowly growing in terms of the amount of JavaScript that your browser has to interpret and execute. Obviously, pages on the web are getting richer. The typical page that used to have a little bit of HTML and some nice style sheet is now a much more complex web application. And one needs to pay attention to the performance of these pages because they directly relate to how people approach and use the web. More data from HTTP archive that was released about a month ago. If we look at things that we need to pay attention to when optimizing web pages, we can correlate that with the load time. And if you look at column number 3, for example, total requests are almost a direct correlation with the load time. And there's two pieces that you should always pay attention to, which is the image transfer size. It has a very good correlation with the load time of the page, as well as at the end, the JavaScript requests. They're very well correlated with the page load time. So when somebody pays attention to optimizations of images as well as JavaScript, that helps a lot directly in speeding up your web pages. And how does load time impact success? Here's some data from several websites out there. Amazon.com did a study where they saw for every 100 millisecond latency decrease, they would increase their revenue by 1%. You can imagine that the scale of Amazon.com, that's quite a bit of money. Edmunds.com worked with us last year. They were working on optimizing their web pages. They used PageSpeed to look at how they can optimize their pages. And this resulted in about 50% load time decrease. The impact on this was about 17% page views per session. And who wouldn't want to increase the page views? This is by focusing on speed alone. Strange Loop Networks, which builds boxes that allow you to optimize web pages on the fly, did some analysis on consumer behavior. And they looked at the consumer behavior of a 3-second delay on what would happen. And for 100 consumer visits, 3-second delays would make sure that about a little bit under 60% of people will just drop off and leave your website. About 50% of them will not return to your website. And that's very important. And worse than this, they're going to tell others not to go to your website. So paying attention to speed is critical for your success on the web. So I'd like to welcome Andrew to talk about PageSpeed Online API.
Thanks. Hi, I'm Andrew Oates. I work on the PageSpeed team based out of Cambridge. And I'm going to talk about the brand new PageSpeed Online API. So first, a little bit of background about the PageSpeed project. PageSpeed is a tool that helps web developers speed up their websites by applying sort of well-known web performance best practices. We launched in 2008 originally as a Firefox extension. And then in 2009, we released the PageSpeed SDK, which lets you sort of build tools on top of the PageSpeed library. Then most recently, we launched the Chrome extension and PageSpeed Online. And so the way PageSpeed works is we have a collection of rules, each of which encapsulates a single best practice, something like minifying your resources or optimizing your images or doing asynchronous fetches. But one sort of piece of consistent feedback we've gotten from developers is that they want a way to run the PageSpeed analysis on their sites and get back sort of an easy-to-consume, machine-readable format, and do this really easy without having to load up a browser and script it or to do a compile against the SDK. And so that's what we're launching today, is a new online API that lets you do that. How does it work? It's super simple. So you can see at the top, you, the developer, make a simple HTTP request to our servers, give us a URL to fetch. We will go out and fetch and render that URL, and then run the PageSpeed library on it, and then give you back the results in sort of a standard JSON format. So here's an example. The top is just a URL you might fetch from. So googleapis.com, PageSpeed Online, v1, run PageSpeed, URL equals, give a URL, and then the key equals your developer key. So if you've worked with Google APIs before, you're familiar with the developer key. Basically, it's just a token that you use to authenticate your request and lets you control and track your usage. And I also have a little Python snippet here that illustrates how you could use it in a language. The response looks like this. Standard JSON, we have the URL you passed in, a response code, the title. We give you the PageSpeed score. So if you're not familiar with PageSpeed, the PageSpeed score is a number, 0 to 100. It basically says how well are you doing. Low scores is bad. You have a lot of room for improvement. And a high score is good. You're applying lots of the best practices that we know about. We give you some stats about your web page. And then down in this formatted results block, we have a chunk for each rule that we apply. So avoid bad requests. I guess Google.com didn't have any bad requests, so it got 100 on that. And then this continues on past the bottom of the slide. So that's all of my slides. Let's do a demo, because that's what we're all here about. All right, so first, let's just take a look at the request response. I don't want to type it out, so here we're going to run PageSpeed on www.google.com, and that's my developer key. Don't steal it. And here's the result. All right, so we fetched it, got a 200. Still got to 99 from when I made the slide. And you can see here all those rules I was telling you about. So avoid bad requests, avoid CSS import, defer parsing of JavaScript, et cetera. And it looks like here's one that we fail, minify HTML. So we get 99 on it. That's still pretty good. And then we have these sort of chunks that let you format this. So this would be great if you were building a tool to present to the users. And actually, if you've used PageSpeed Online or any of the PageSpeed products, we use this exact same API in sort of various forms internally. So you can build the same tools that we have. We're also launching with the 40 language support. So let's say locale equals Korean. Oh, and hey, avoid bad requests. That's how you say avoid bad requests in Korean, I guess. I don't speak Korean. So now I'm going to show you a quick demo of how you could use this in your development environment. So I put together this little website, Andrew's Vacation Photos. And it's my vacation photos. Really simple. Has some images on it, some CSS. Let's take a look at what it looks like. Loads 5 images, but I really care about web performance. I want people who come to see my vacation photos to have a really snappy experience. So I have this script. I call it push-and-test.py. And basically what it does is it lets me push a new version of the site to App Engine. This is hosted on App Engine. And then test it, do an A/B comparison against the old version and see what's changed. So you don't worry about the push version script. That does some fancy stuff with hashes in the App Engine environment. And then I have this function test URL that basically it reads the web page and counts the number of image tags and makes sure that it's greater than 2. So let's give this a shot. Push and test.py. Oh, and there were no changes. Testing, OK, great. Now Now let's see how we can integrate the PageSpeed tool with this. So let's add a function. If you don't know Python, you should be able to follow along anyways. It's pretty simple. Get PageSpeed results. Take in a target URL. That's the URL of the site we want to analyze. So let's build up our URL parameters. Target URL. And my developer key, which I don't remember. So you can get this if you go to the API's console. Just sign up. Enable PageSpeed Online API. We're live right now. And you can get your own developer key and try this out. All right, so now let's construct our URL. So we want HTTPS, googleapis.com, PageSpeed Online, v1, run PageSpeed, which is the only thing we can do. And then we're just going to encode that, those URL parameters as a string. All right, let's fetch that URL. And then let's parse it as JSON. So I like Python a lot because you can do this really easily. Load string response. All right. So you can see I have two URLs here. Anna's vacation photos and 0.latest Anna's vacation photos. I'll explain that the next time we're waiting for App Engine. So let's get our PageSpeed results for both of those. Analyzing old page. Stable URL. Analyzing the new page. And let's do test URL. And we can delete this old stuff. All right, so let's just make sure this is working. Let's print out the results that we get. And let's give it a shot. Analyzing the old page, analyzing the new page, and that looks like JSON. Awesome. So notice it takes a few seconds because we have to fetch the page and render it and do all this analysis on it. So now let's look at the PageSpeed score. So let's say if the old results score is greater than the new results score, score decrease, it's a hard word, and then we'll print the old results and the new results. Otherwise, we're doing OK. We haven't introduced any regressions. And let's print the PageSpeed score for good measure. Old results score. All right. Oh, new results. Thank you. Feel free to speak up if I screw up. All right, analyzing old page, new page. OK, PageSpeed score, 84. OK, so I have some room for improvement, but I haven't introduced any problems, which is true because I haven't made any changes. So let's make a change. Let's say I want to jazz my site up with some jQuery. And I have it commented out here because I can't remember the URL. So we're going to load from the Google-hosted version. If you've used this before, you might notice I'm not loading the minified version. That's my mistake. And we'll see why in a second. Type equals. And let's say whenever you mouse over an image, let's give it a red border. Because I like gaudy things. Shawn knows. All right. Let's push and test. OK, so here's the App Engine magic. So App Engine lets you upload multiple versions of a site, and I'm using that to my advantage here. Basically, I'm uploading one version, but keeping the old version around. And then I can do an A/B comparison. And then does this exponential back off. OK, analyzing old page, analyzing new page. Score decreased 84 to 74. So let's just double check and make sure this is doing what I think it's doing. Refresh. Yep, that's working for some definition of working. Score decreased 84 to 74. So in this case, it's pretty simple to figure out what I did wrong. I only added one chunk, right? But let's say I did a really complex change, and I want to know more about what's going on. So I can do that. So let's go back to the script. OK, so let's add a new function. Let's call it compare results. Let's do old results, new results. And so as you saw briefly, we give the results, they're formatted, and then we have this structure called rule results, which is a dictionary which maps from rule names to result blocks. So we get it for the new and the old. All right, so now let's say for every page speed rule in the old one, in the old results, and this is going to assume that the page speed library didn't change between these two invocations, which is a fair assumption for this demo. So let's say if the old, get the result block, and let's say rule score. So we also assign a score to each rule. Is the greater than the same thing in the new results block. That means that this rule, the score is decreased. So it's a pretty good bet that this is the change that's causing a problem. Let's print rule was triggered. And then let's give the localized name of the rule. So if you were making this tool to publish, for instance, you could grab the locale out of from the client, and they would see these strings. Well, not the strings you're writing, but any page speed strings they would see in whichever locale you choose. All right, I think that'll work. All right, so if old result score is greater than new result score, let's also do compare results, old results, new results. Oops. All right. Cross your fingers. Analyzing old, analyzing new. Score decreased 84 to 74. Rule triggered defer parsing of JavaScript and minify JavaScript. OK, so it's something to do with JavaScript. Let's say, though, that I only have a few minutes. I really want to fix something. Which one of these is more important? Well, PageSpeed can tell us. We also assign something called an impact to each rule. So basically, the score will tell you how badly did you do on this rule. So you can get a 0 on a rule, right? And that means that you're doing really badly on it. But if it only affects one teensy tiny part of your page, you probably don't care that much. There could be another rule that you did OK on, maybe got a 75, but it affects a large portion of your page, and you would get a lot more out of fixing that. And that's what the impact means. So let's add the impact here, so we know what we want to fix. I'm just going to run over my line. Oops. So new rule results, get the rule, and rule impact. And all of this is documented. You can just stick it in and play around and take a look at it. It's also all documented on the code site. So let's try it again. Oops. What did I change? Did I not close my bracket? Well, that's odd. Bear with me. Let's try this. I'm going to force it to push a new version again and see. So let's check to make sure it's OK. It's still doing the odd jQuery thing. So we set caching headers on the PageSpeed responses. So if there was a weird cache in between PageSpeed and me right now, that might. There we go. Perfect. OK. Score decreased 84 to 74. Rule triggered defer parsing of JavaScript. Impact 1 point whatever. Minify JavaScript. Impact 9.3. OK, so minify JavaScript has a lot more impact on my page than deferring parsing of it. So let's focus on fixing that. So let's edit index. I can look back. Oh, oops, I forgot to use the minified version. Fortunately, I can just add that. So minification, if you don't know, is basically the process of removing anything extra. So your JavaScript file will have comments and white space that aren't necessary to executing the JavaScript, but are necessary for reading it. So when you minify, you strip all that out, and you can make your page run a lot faster, or the resource load a lot faster. So now let's run it and see what happens. It's going to push again, waiting 2 seconds, 4 seconds. And this is a really simple example. So we're designing this so people can build PageSpeed-like tools. Oh, OK, PageSpeed score 86. So we fixed the problem. You also notice the score went, oh, this is a little cut off. That's OK. the score went up a little bit. The reason for that is we made our page heavier. We added a whole bunch of JavaScript to it. And so as a result, any deficiencies that were there before sort of matter less in the grand scheme of things. And that's why our PageSpeed score went up by a few points. And so that's an example of how in just a few minutes, I integrated the API, built this regression testing tool that will help me catch these performance bugs. Maybe I would have launched the site without realizing it. I would have, 2 months later, found out that I'd been losing traffic because of this regression. All right, let's go back to the presentation. Oh, we lost our place. So we're launching this today. You can go try it out now. Also launching today is W3 Total Cache is adding integration with us. So here's a screenshot that the creator of W3 Total Cache sent us, showing this is the exact same UI that we have in all of our PageSpeed products. He integrated it with the PageSpeed Online API and just inserted it right into his performance dashboard. And that's the sort of product integration and tools we want to encourage with this. Is basically lower the barrier to entry to using the PageSpeed library in tools and workflows and all that other good stuff. If you want to learn more, that's a giant QR code for our docs, as well as the actual URL and a Google URL. You can scan that in and get started right away. And that's all I have. I'm going to hand it off to Shawn, who will talk about Mod PageSpeed.
All right, how you guys doing? I'm Shawn Ligocki, and I'll be talking about Mod PageSpeed. Mod PageSpeed the idea is to automate some of these rules, these PageSpeed best practices on a server so that you don't have to do it yourself. Right now, it's the Apache web server plugin, and it rewrites your HTML and your resources, and it's an open source product. You might ask, why do I need to use Mod PageSpeed? Can't I just implement all these optimizations myself? And there's a couple of reasons you might want to have something automated, but one of them is that a number of these things, specifically I'm going to be talking about leveraging browser caching and combining images into CSS sprites, can be kind of difficult to do and specifically to maintain if you do them yourself. And so to talk about these a little bit, I'm going to go into some detail about why you want to do these in the first place. So the first one is our extend cache filter. And this is, the basic idea here is you have a cache. So by default, your cache lifetime for most resources is going to be about 5 minutes. And here's an example of what happens. This is the initial request the user makes to your website. And this is going to be covering a single resource, so one image on your site, one CSS file. And then here's the response that comes back. And you can see kind of the response. There's a lot of content there because it's a whole image or a whole CSS file. And then if your user then goes ahead and visits the site again, maybe let's say 4 minutes later, they're actually going to make no request all the way to the server because they still have the resource cached in their browser. But if they go visit, let's say 6 minutes later, they're going to have to go and ping your server and say, this resource is expired out of the cache. Is it still good? And your server has to respond back saying, yep, it's still good, 304, not modified. And this kind of repeats forever as they come to visit your site again and again over the next minutes, hours, days. Each time they visit after 5 minutes, it's going to have another response. And you might say, this is just a really simple request response. It should be really short. But it's a whole round trip, which can be tens, hundreds of milliseconds. And as Richard pointed out, there can be 50 images, hundreds of resources on your site. If each one has these round trips, it's expensive. And so the best practice is to have longer caching lifetimes. So what if you just set your cache lifetime to 1 year? This looks great, right? I mean, now you have, there's nothing. You load it the first time you have to, and then you never have to go to contact the server again. And it sounds perfect, except of course, what if you ever change that file? And if you change it, just say like 13 minutes after the user visited the first time, they might not notice for another year as it stays in their browser cache. Probably less than that, but maybe like a week, a day, anything like that. That whole time, if your JavaScript, let's say you fixed an error in it or you updated the versions of your JavaScript, now they're going to be out of date. So most people, when they put cache headers on their files, they put reasonably short cache headers. And the reason is that now, let's say here's again the 5 minutes. Sure, you're doing these pings every once in a while, but this time the ping really matters. This time the ping tells you should really update your request and download the new resource. So a question you might want to know is, well, can we get both? Can we get the best of both worlds so that we don't have to keep pinging the server when the thing's not updated, but we can ping it and get the actual result, the new updated resource when it is updated? And that's exactly what we've done in Mod PageSpeed. So for the whole time that it hasn't been updated, you don't do anything. And then finally, when it has been updated, you go ahead and ping the server, get the new response back, and get the updated resource. So that sounds great. How do you do it? I'm going to go into a little detail here. If this is the original thing, it's just an image, walrus.png. And now when we rewrite it with Mod PageSpeed, we're going to change the URL. We're going to add, specifically, you're going to note this hash code here, which is the 91_WW. And that's MD5 hash of the contents of the file. And so every time this file changes, you're going to have a different URL. And so it's going to tell the browser you have to update. And so now you can see that we can add, this is the original cache lifetime. We added 5 minutes to have as much control over our website as possible. And now we can extend it out to be a whole year long. And whenever the file changes, here's the new hash code. Automatically, when you load the new HTML file, you're going to get the new resource, the new image, the new CSS. And that's how we can avoid all these extra checks, but still get it updated after you've updated your resource. Another example I'm going to cover is spreading images. The idea here is that if you have probably multiple images on your site, Richard showed that the average site has 50 images on each site. So here we just have an example with 3. Each one of these, you're going to have to make a request out to the server and a response back. It's a round trip, and then get the results, and another request out, response back, get the results. And in addition, each time the user visits the site again after some time past the caching date, it's going to have to make these again 3 round trips for each of the images, or 50 round trips, you have 50 images. So you'd like to be able to just get rid of all the extra round trips to say, I want to request all the images and get them all back. And then each time I can just make a single ping to say, is this still up to date? And that's exactly what we do, except that in addition, of course, we also cache extend it. And so you don't even have to do those extra pings until the images actually change. And how do you do this? Well, in this case, here, let's say this is our original page. This is the original CSS file. And you have these 2 PNGs here in different backgrounds. And now when you've rewritten the page, you have them both combined together into a single URL. It's repeated twice here. That's one resource that's going to be loaded. And each of these have offsets to tell the CSS which one to show. And so if this is the original images, these are just the 2 images put together. And we do the same thing with CSS files and JavaScript files to be able to combine them to reduce the number of round trips that we need to make to the server. Great, so this is some of the motivation for why you might want to install Mod PageSpeed, why you might want to automatically rewrite your web pages. And so here's a little information about how you could install it. If you're using GoDaddy or DreamHost basic hosting, it's actually already provided. All you need to do is sign up with clicking a little checkbox or putting in a small configuration file, and you can test it out. If you're using CentOS or Ubuntu, there's binary downloads you can put into the package manager. They'll automatically update themselves. And of course, it's also open source, so it's available you can build from source using instructions on the website. In addition, as soon as you download it, it'll already start rewriting your web page in ways that we think are both safe and really useful for your site. So it has a kind of a core set of filters enabled to rewrite your site. But in addition, we provide lots of configurability. You can do a number of things, simple things like turning Mod PageSpeed off, so you can just do it for testing. You can change the default set of rewrite level to more conservative or liberal levels. And you can turn on and off individual rewrite passes to do things like removing comments to spreading images, things like that. And there's some more detailed configuration options you can do. One of the big helps that Mod PageSpeed can provide is rewriting images. If you have large images that are represented in small size on your web page, you can really resize those. And even if they are the same size, often you'll have extra meta information that's unnecessary. So we can run through OptiPNG and other optimization software to reduce the size of the images. But that's kind of it can be CPU intensive, so you can set the number of images to be rewritten at the same time. And there's other things you can set up depending on your local architectures. Great, so let's say, so now that you've installed Mod PageSpeed, you might want to know, how do I really know that it's helping my page? And this is what we'd love to get your feedback on and see how it's working for you guys. And we have 2 examples that we're suggesting for how you can go out and check this. And the first one is PageSpeed Online. It's the tool that Andrew's team released a couple months ago. And you just go to the website and input your URL, and it tells you what the PageSpeed score is for your site and some suggestions that you want to follow. And so by using that before and after, you can get some feel for how much is it actually implementing those decisions? Is it improving your PageSpeed score? In addition, you probably want to know how much is it actually speeding up your site. And so Web Page Test is a nice website that allows you to actually go and load using an IE browser in a real location, along cable modem or something like that, and to actually see how long it takes for the page to load, how you can see the waterfall diagrams and all the details about it. And so I'm going to actually go through and demo some of these to show you how you can test this. So here's PageSpeed Online, and in this case, we're going to be testing one of our user sites, which is Android Academy, and we're going to set it first to get a baseline with PageSpeed turned off. Great, and so here you can see that the PageSpeed score is 69, and here they have some examples of things that you might want to do on the website to make it faster. So specifically here, notice, it's leverage browser caching and combine images into CSS sprites. And these 2 things that I just mentioned that Mod PageSpeed can help you with. And in addition, there's also a yellow one for inline small CSS files, which we also do. So now we go ahead and let's say we can open this in a new window so we can compare them. And let's try loading. Just the page with no query params so that we get the actual Mod PageSpeed version. And great, so as you can see, this increased all the way to 79 points. It's up 10 points, which is almost 15–20%. And in addition, the leverage browser caching is down to a yellow item. The inline CSS is gone. You'll notice that combine images into CSS sprites is still here. You might ask, why is that? I just mentioned it. Inlining images into CSS sprites is a new feature that we're releasing. We haven't worked out all the details yet, and we haven't suggested people's turned on yet. So that's kind of an example of something that we can still be working on for this site to provide value to it. And for the leverage browser caching, so you might say, well, we reduced it from a red item to a yellow item, but it's still on there. Why is it on there if we can just leverage all the browser caching? Well, if we look into this a little bit, we can see, glancing at this, there's maybe 15 or 20 of these guys. It seems like that's kind of a lot of things we haven't been able to increase the cache lifetime on. If we look at the original one, there's actually like 40 to 50, maybe 100 of these. There's quite a number. And so we've made a significant improvement. Each of these is, again, like a round trip when you visit the site again. And so reducing it from 100 down to 20 is an 80% improvement on that kind of load time in some ways. And in addition, so probably what's happening here for these, why these aren't being inlined, they're probably something in an AJAX call or a JavaScript that's we can't find when we're rewriting the page. And if that's the case, then it's probably actually not so bad, because if they're in an AJAX call, that's probably after the page is already loaded. And so it's not going to impede sort of you seeing the page that they're not cache extended. Might be a pretty good thing. So here you can go back and look at the summaries, and you can compare these as one way of seeing how good your optimizations were. But another example, go lost place. Right. But you might say, your mod page speed, of course you're going to improve the page speed score. What does that really tell me? And so it's another good example to go check out is Web Page Test, which, like I mentioned, will actually go and load this page from a real browser. You can choose whether you want to load it from IE, from Chrome, and there's a number of different locations. You can pick one where you think your users are going to be, or test from different locations in the US and internationally. And specifically, we'd suggest if you're doing this, you up the number of runs, because one run doesn't give you very good statistical significance. You could have a bad run, bad network, things like that. And so we suggest you up it to about 10, which is the maximum, and just see, it'll tell you all the different runs. You can see the distribution of it, and it'll specifically point out the median time, which is kind of what your average user will see. I'm not going to run this one live because there's kind of a queue for waiting for this, and so it could take maybe 10, 20 minutes to run through. But I have some examples saved here. This is also from Android Academy. Here's the before, and as you can see at the top here, we have a bunch of metrics about load time, start render, first paint, things like that, and the number of request size. And if we look down here, we can see the waterfall diagrams. And the first one here is the initial load, and the second one here is the return load. You can see there's less resources, and maybe it's a little hard to see because it's in the middle of the page, but there's less resources loaded this time. All the yellow ones are the ones I was mentioning earlier. This is when you just ping the server and it says the resource hasn't changed. So in some ways, these are a little bit wasted, and you can see that it actually takes quite a bit of time to do all those yellow responses. And you can go through those 10 responses here. This is the afterwards, and if we just glance down at some of these results, we can see that, let's say, this repeat view is much smaller. And presumably what we've done here is eliminated all these pings we had to make back to the server for these sub-resources by extending their cache lifetimes. And so now, and you can see specifically, it's not just from the image, but the actual hard numbers here. There's 42 requests made on the repeat view after we turned on Mod PageSpeed. And if you go back to the original one with Mod PageSpeed off, there's 95. So it's less than half of the number of requests. And that can make a big difference. And it's not just the number of requests. If you look at the start render time here, it's 3.2 seconds. Afterwards, it's 1.2 seconds. I mean, it's even less than half the time to first get the first paint on the screen and let your user know that something's happening. And the finish time here afterwards is 3.6 seconds. Before it was 6.1, again, about half the time. So this is, it's a pretty significant change in how much loading time if you have users coming back again to your site. And so, yeah. And so we'd love to hear you guys telling us about how, if you get a chance to install this on your site and to run through some of these tests and see how it works for you, how it improves your sites, et cetera. And if you'd like more information, all things, kind of the Center for All Things PageSpeed, so the URL up here, you can also just search for us. In addition, we'll be having sort of office hours down in the pub lounge, which is right down at the bottom of the stairs, take a left, where people were eating lunch today. We'll be there until 6 p.m. For one-on-one. And in addition, if you're interested in these topics, you should check out, there's 2 talks tomorrow at Google I/O. Josh Morant's giving one on Mod PageSpeed tomorrow at 11:30. And Brian McQuaid's giving one on PageSpeed for mobile browsers. And that's going to be in the afternoon, 3:45.
So actually, I have a second demo that we weren't going to do, but we have time.
Okay.
We have about 20 minutes. So I'm going to show you the advanced features of the PageSpeed Online API. And by advanced, I mean everything that's left. And I'm going to attempt to build an entire PageSpeed tool in the next 15 minutes. And you guys can help. Yeah, whoever that was, thank you. All right, so let's take a look at what the results look like. So before we were just looking at the rule names, but as you can see, where's that little thing? So as you can see, we have a lot more than just a rule name here, right? We have a rule score, an impact, this URL blocks, and this header, and the format, and these args. Basically, this is what we use in PageSpeed Online and PageSpeed Chrome and PageSpeed Firefox to construct the actual UI. And it's really simple. How it works is this. We have these format strings. The following external resources have small response bodies. Inlining the resources, that's a bad example. Let's do this one. $1 should inline the following small resources. And then we have an argument, type URL, value, that. So basically, as a developer, you can just stick in this URL in place of the $1. And is there a better example? And what that lets you do is, here we go. So here's a list of resources that don't have good cache lifetimes. So we have a $1 and a $2. $1 is the URL, identification photos, media photo 1. That's the shells, I think. And then a duration, 10 minutes. And what this list lets you do by giving you this flexible format is it lets you format things differently. So for instance, in PageSpeed Online, what we do is we take these URL arguments and we turn them into links the user can click on to go to a different thing. And I think we bold durations or we italicize them or something like that. So it's a really flexible format. So let's extend our script to use these. So let's just do let's just do print results. So let's take in some PageSpeed results, and it'll print them out in a flexible format. So, and again, this lets you leverage our 40 language support so that your users all over the world can see this in the language of their choice, the locale of their choice. All right, so let's see. This is, OK. So we're going to get the rule results from, as we did before. Results equals results, formatted results. Same thing we did up top there. And for every rule in the rule results, let's just print out a header. Rule results, rule, localized, rule name. Print results, let's just print out whatever the new results are. Push and test. Oops. Analyzing old, analyzing new. OK, so we've listed the rule names. Let's augment that. So I'm actually going to just comment this out for now. We're just going to print the PageSpeed results. And we have, we're going to have snippets, examples posted online for JavaScript and Python and some other common languages for how to do these things. All right, so if you look at, this is my saved version in case the internet broke. If you look at this rule results block, we have the name of the rule there, a localized rule name, and this URL blocks thing. And what the URL blocks is chunks of URLs that are related. So for instance, you might have one URL block per redirect chain. You would say, this redirect chain should be eliminated. This redirect chain should be eliminated, and so on and so forth. So for URL block in rule results rule URL blocks, so let's just print out the header. Oops. This is the danger of a live demo that has not been rehearsed. URL blocks, header. For URL block in rule results rule, URL blocks, header. If there are any Python gurus who want to pipe up and tell me what I'm doing wrong. Oh, yeah, well, that's a possibility. Well, let's test to see if URL blocks. There we go. Thank you, Brian. So let's do this on a more interesting page, actually. Let's do it on news.google.com. And again, bear with me. This is a little by the seat of my pants. OK. What, Brian? This is my manager, Brian. He's helping me out. Oh, yeah. Say that again? Bingo. Analyzing. There we go. OK, so you can see for each one of these headers, we have a format, which is this string, and we optionally have some args. So let's write a little function that will fill that in. Fill format string. Let's just call it header. If something just beeped at me. Oh, it's running out of time. All right, otherwise, for each argument in the header, and this is pretty boilerplate. We have examples of this online. There we go. I already have this written. I knew this felt familiar. Oops. All right. Fill format string dictionary. So line 106, instead of printing the header, let's print out fill format string the header. Let's see what that looks like. Oops. Analyzing the page. Analyzing the page. Isn't it fun watching people debug? Oh, right. If args not in format string dictionary, return format string dictionary format. Cross your fingers for me. Damn. Args equals format string. This is clearly buggy code. Format string dictionary args out equals sub I plus 1 args I out return out. What line is this on? 108, 98, 82. Unhashable type dictionary. Fill format string, URL block. Line 70, thank you. What was the error again? The high caliber of Google engineers illustrated in front of everyone. Line 70, re.sub. This is infuriating. Oh, right. So we have a type and a value for each of these. So this needs to be the value. Oops. Let's see if that works. And there we go. OK, awesome. That was harder than it should have been. It's going to be so smooth now. All right. Minifying the following JavaScript resources can reduce their size by 2.3 kilobytes, 0% reduction. So it worked. So let's indent that. All right. Now let's look at the results and dig down a little further. So in this URL block, we have the header. And then we also have, optionally, this list of URLs here. Each one of these has a result. And the result is the exact same format as the header. So if URLs in URL block for URL in URL block URLs. There's a better way to do this in Python, but I'm not going to bother with that right now. If result in URL print 1, 2, 3, 4, 5. Why not? Plus fill format string URL result. Knock on wood. There we go. So the following cacheable resources have a short purchase lifetime, specifying expiration date of at least 1 week in the future for the following resources. And then for each of these, we give a URL and that. All right, there's one more step as our indentation gets further and further. If details in URL for detail in URL details print 1, 2, 3, 4, 5, 6, 7 plus fill format string detail. Push and test, analyzing. Looks good. Let's do one more thing. Instead of doing that URL, let's take it in from argv. argv1. So now we can do push and test. Give me a URL. Anyone. Let's do Android Academy. www.androidacademy.com. Drum roll. Takes a while. Analyzing. And there we go. Page speed results. I did that in 8 minutes. You can do better, I'm sure. Thank you.
Please join me back. Shawn and Andrew were showing you many simulations of what your page speed would be. Like web page test is a nice simulation of what your web page latency would be. Last week on Thursday, Google Analytics announced that now if you have Google Analytics on your site and you add one line to your site, we actually collect your site speed and show it to you in the dashboard, in the Google Analytics dashboard. And that will be a great help for you as you see the real world client-side latency that you expect, that you want to see, as opposed to the several sites where web page test servers are, or some localized pages. So we have a few minutes. If you have any questions, please go ahead.
Yeah.
Yeah.
So when you do this online page speed test, how is latency taken into account? You test on different sites, or is it only the weight of certain rules? I can imagine that for Chinese users, your page, some elements are just more important than for others.
So for PageSpeed Online specifically, we actually don't take the number of seconds that it takes to load the page into account. For one thing, for PageSpeed Online, it's Google loading it. Google has a lot of fast internet connections, so it wouldn't be representative. For another thing, our focus, so there are tools out there to do that. For instance, web page test is sort of a full solution, and it'll give you stats about actual page load time.
And you can go ahead and load that from China. They have servers all over the world.
So for PageSpeed itself, we're focused more on what sort of, irrespective of things like the actual connection you're on, what kind of server you're running, if you need to have more boxes on the back end. What can you do on the client side for these development best practices to speed up your site?
Although you guys do also have specific rules for mobile sites, right? A specific different way to weight things.
Yeah. So one thing we launched recently with PageSpeed Online, and Brian and Lebo are going to talk about this at I/O tomorrow, is specific new PageSpeed rules. So mobile is obviously a big growing space, and phone connections are really slow. And RTTs will be on the order of seconds instead of milliseconds. And so every connection you save, every request, can have a huge impact on your site in terms of views, revenue, et cetera. And so we launched some new rules in the mobile space to help people optimize for those situations.
Any more questions? Yes.
Yeah. So a lot of what we're looking at right now when we're testing this is how do we choose which images we should be spreading together and how we should be doing this. And in general, right now, we're focusing mostly on images that are already in the CSS, are already written in CSS. And so what that means is if you have foreground images listed in an image tag, those are more likely to be a kind of an important user experience to load early. If you can combine a bunch of very small images that are like part of your Chrome, your rounded corners, little smiley faces, things like that, that can be helpful, and it might not even actually slow down the load of the whole thing.
And for like a lot of these things, it's a trade-off, right?
Yeah.
If different connection types have different characteristics, you might have something like a 3G or a 4G connection on a phone can have actually a fair amount of bandwidth, but really high RTTs, really high latency. In that case, if you can just dump everything down with one request, you'll save a lot of time rather than having to go back and forth to the server for each one of those small images. And so finding where that trade-off is sort of an important part of the process.
OK. All right. Well, thank you very much. And we hope you enjoy the rest of IU Bootcamp.